Welcome to Inequalities and Systems for Pre-Calculus of Math 11. Today we're taking a look at graphing quadratic inequalities. So last section we took a look at graphing linear inequalities. This time we're going to change those into quadratics. So if quadratic equations in standard and general form create a graph called a parabola, which we've seen already. When graphing a quadratic inequality, we can use the same technique that we used for graphing linear inequalities, and the only difference is that we either shade inside or outside the parabola, and we can use a test point again or just simply reason. So let's say we want to graph the inequality y is greater than a half x squared minus 6. Just like in linear inequalities, we're going to make sure that we have this in standard form for a parabola. Standard form for a parabola, remember that y equals kind of an a x minus p squared plus q idea, which we actually have here. The vertex here is at 0, negative 6. There's negative 6. It's vertically compressed by half, or the y values are scrunched down by half. So instead of out 1, up 1, it's out 1, up half. 2, 4 goes to 2, 2. 3, 9 goes to 3, 4 and a half. 4, 16 goes to 4, 8. And we can probably get a pretty good curve based on that. And notice that it is an inequality without an equal sign, so we're going to go dotted lines on this one. A little bit easier for me to hit all the dots when I'm drawing dotted lines here. So there's our parabola. Let's do this using maybe a test case. Let's test inside the parabola, and a point that's inside the parabola is certainly 0, 0. Again, similar to in linear inequalities, might be worthwhile to use 0, 0 as much as you can. We'll test whether 0 is greater than a half 0 squared minus 6. Half of 0 minus 6 is 0 greater than negative 6. Basically, you bet it is. So we are going to shade inside of that parabola. So there we are. Because 0, 0 worked, we're going to shade inside that parabola. Pretty straightforward, right? Just graphing quadratics, which we've done a lot of. Why don't you try the second example? Hit pause. All right, we're going to put this in standard form. Is it already? Let's see. We have y greater than or equal to negative x minus 2 squared plus 3. Yeah, it does look like standard form. We're going to shift it to the right 2, or a vertex of 2, 3. It's opening down. It's standard expansion, so out 1, down 1. 2, 4. 3, 9. Get those points. It is a solid graph. Let's see if I can hit the dots in one stroke here. Well, that's not too bad. And heading the other way. So solid line because of the inequality. Let's test a point. You know what? 0, 0 here looks a little bit too close for my comfort. I mean, I'm drawing it a little bit differently. You could use 0, 0. You could reason out that 0, 0 isn't on the curve because that would have to be just over 2 up 3 rather than over 2 up 4. But let's try something else. Let's try, let's pick something way to the left. Negative 5, 0. So we're going to try a point over in this region here. 1, 2, 3, 4, 5. This point right there. So we're going to go into y greater than or equal to negative x minus 2 squared plus 3. Y value is 0. Negative 5 minus 2 is negative 7. Remember, when you square negative, it should become positive, so that's 49, which makes it negative 49 plus 3, which I'm saying is negative 46. Is 0 greater than negative 46? You bet it is. So we want to shade in the region of negative 5, 0, which is outside this parabola. So there's my shading outside. I'm not going to do everything, but certainly the points that are outside here. How would reasoning really work here is you're just looking at the parabola and you're saying the y values, again, which are either above or below a parabola. So in this case, it was all the y values that were above the parabola. The equation, the thing containing the x that defines the line, we want all the y values above it. So working backwards, certainly need to be able to do this. Determine the equation of this curve. We see a vertex of 1, 2, 3. So the vertex is at 3, 5, it looks like. From the vertex, we head out 1, down 2 in this case. So the a value is definitely negative because it's opening down. And because normally it's 1, 1, now it's gone to 1, 2, it's doubling. So let's write this equation. There's a y. It's negative 2 x minus 3 squared plus 5. Now let's figure out the inequality. It's definitely an equal sign because it's a solid line. And reasoning this case, or if you want a test point again, let's try reasoning here. It's the region that's shaded in inside the parabola, which is all the y values that are below the curve. So we want all the y values that are smaller than the curve. So there we go. Y is less than or equal to negative 2 x minus 3 squared plus 5. Let's move on to some word problem. Two numbers are related in such a way that the difference of 4 times the square of the first number and 6 is less than 2 times the second number. Sounds terrible. I understand that. But we're always going to let x and y be our two numbers, be the two things. So let's just go through this. Two numbers are related in such a way such that the difference, okay, so we're talking about some sort of difference. Difference means subtraction. The difference of 4 times, well, let's just go with 4 times. So the difference of 4 times, so it's 4 times some number, maybe you use a little dot there to show that it's times. The square of the first number, so let's say x is the first number. So there's 4 times the square of the first number. And it's the difference of that and 6. Okay, so minus 6 is less than, so that's important. We're going to a less than symbol, not less than or equal to, just less than 2 times the second number. Okay, so 2 times our second number here is y. So we end up with 4x squared minus 6 is less than 2y. Again, let's put this in standard form. Divide by 2 makes it 2x squared minus 3 is less than y. That is standard form. We have a vertex of this case of just negative 3, sorry, 0, negative 3. It is expanded vertically by 2, so out 1, up 2, out 1, up 2, 2, 4 goes to 2, 8. Looks quite narrow, this one. It is a dotted line. So there's our dotted parabola. And shading wise, we want all the y values which are bigger than that parabola. Or again, why don't we try testing a point again? Let's test 0, 0 is 4 times 0 squared minus 6 less than 2 times 0. So on the right hand side we have 0, 4 times 0, 0, negative 6. You bet that is. So we are shading all the y values which are above the curve. we go. So that's us graphing the equality. And then it's asking us to list two numbers that meet the restrictions. Well, 0, 0 certainly worked, so why don't we try that one? And we could also go with 1, I don't know, 4. So just to show two numbers that do fall within the desired range. So any numbers in that region satisfy this inequality. This ends the notes for graphing quadratic inequalities, section 5.3.